Welcome to The Explainer. Today, we're going to dive into a really fascinating mental trap. It's one that makes us choose a compelling story over the hard facts pretty much every single time. We'll be breaking down a classic experiment from Daniel Kahneman's amazing book, Thinking Fast and Slow, that shows just how easily our brains are wired to, well, judge a book by its cover.
All right, let's just jump right into this with a little challenge. We're going to put your intuition to the test with a simple puzzle. I promise there are no tricks here, but the result, well, it just might surprise you.
So here's the setup. I want you to imagine a graduate student. We'll call him Tom W. He's studying at a big state university. Now, with only that little bit of information, I have a task for you.
Okay, so your first job is to rank these 9 fields of study. We've got business administration, computer science, engineering, humanities and education, law, medicine, library science, physical and life sciences, and social science and social work. Just take your best guess and rank them by how many graduate students you think are in each field, from the most popular to the least. Don't worry about being perfect. This is just to establish what we call a statistical baseline.
You see, the whole point here is something called the base rate, which is really just a fancy way of saying how common something is. Since there are way more students in fields like humanities and education than in, say, library science, the pure odds are that any random student like Tom W. would come from one of those bigger fields. It's just a numbers game.
So you've got the statistical odds in your head, but now I'm going to give you a little more to go on. A personality sketch of Tom W., written by a psychologist after a few personality tests. Let's see what we've got.
Okay, with that description in mind, I want you to re-rank those same 9 fields, but this time you're not ranking them by numbers. You're ranking them based on how well Tom W. fits the stereotype of a typical student in each one. Does he sound more like an engineer to you, or maybe a social worker?
Now, most people come up with a list that looks a lot like this, putting computer science and engineering right up at the top. I mean, the need for order and the corny puns, that just screams computer scientist, right? It's the classic nerd stereotype. And his little sympathy for other people makes him a pretty terrible fit for something like social work. So you've just created a ranking based on similarity, on what just feels right.
All right, now for the final, and really the most important question. We've looked at the hard numbers, the base rates, and we've looked at the personality sketch. It's time to put it all together.
So, what's your final call? I want you to rank those 9 fields one last time, from most to least probable, based on all the evidence you have. What is Tom W.'s actual field of study?
And this is where it gets absolutely fascinating. When people make their final prediction, something really strange happens. As you can see here, for almost everyone, and I mean even statistics graduate students, the ranking based on probability ends up looking identical to the ranking based on stereotypes. It's as if the base rates, those actual enrollment numbers we started with, just completely disappeared from the equation.
So, what in the world is going on here? Well, our brain performs this brilliant but totally flawed magic trick. It takes a really difficult statistical question, calculating actual probability, and it secretly swaps it for a much, much easier one, judging similarity. Does Tom W. look like a computer scientist? Yep. So we conclude he probably is one, completely ignoring the fact that computer science is a pretty small field in the grand scheme of things.
This mental shortcut actually has a name, and it's one of the most powerful biases that shapes our thinking. Understanding it is absolutely key to making better judgments.
This is called the Representativeness Heuristic. You see, our brain loves a good story. We see a description that perfectly matches our mental image of a nerd, so we immediately jump to the conclusion that he must have a nerdy profession, and we completely forget about the statistics.
A perfect real-world example of beating this is the whole Moneyball story. For decades, baseball scouts were totally fooled by representativeness. They just drafted players who looked like they should be stars. But Billy Beane ignored the stereotypes. He focused purely on the base rates, the players' actual performance stats, and he built a winning team on a shoestring budget.
Now, look, relying on representativeness isn't always a bad thing. Stereotypes are sometimes true, right? Tall people are, in fact, more likely to play basketball. But when we rely on it and nothing else, we commit some pretty serious errors in judgment.
The first major sin is that it makes us fall in love with long shots. If a story is compelling enough, we'll actually bet on a rare event, completely ignoring the fact that it's, rare.
Let's try another quick puzzle to really see this in action. Imagine you're on the subway and you see someone reading the New York Times. What's more likely, that they have a PhD or that they don't even have a college degree at all?
Now your gut, your representativeness heuristic, is probably screaming PhD.
But the base rates, they tell a completely different story. And this just illustrates it perfectly. While reading the Times fits the stereotype of a PhD, the sheer number of people on the subway without a degree is vastly, overwhelmingly larger than the number of PhDs. So the statistically smarter bet is that they don't have a degree. Representativeness points one way, the actual probability points the other.
And the second big sin is that we totally ignore the quality of our evidence. Remember that personality sketch of Tom W? The original problem explicitly told you it was based on tests of uncertain validity. But let's be honest, did that stop you? Probably not. Our brain just grabs onto that vivid story and forgets to even question where it came from.
So, if our intuition is so easily fooled, what can we do? How can we fight back? Well, the solution is in a more disciplined way of thinking. You might have heard of it. It's called Bayesian reasoning. It sounds complex, but trust me, the core idea is really simple.
It really just boils down to two simple, powerful steps. First, always start with the base rate. Before you get swept away by a good story, just ask, what are the general stats here? And second, you have to critically examine your evidence. Ask yourself, how much should this new information really change my mind? Is it strong, reliable evidence, or is it kind of flimsy?
So here's the crucial takeaway. The correct way to solve that Tom W. puzzle isn't to completely ignore the personality sketch, but to give it very little weight because we were told it was unreliable. You should anchor your judgment in the base rates, the actual enrollment numbers, and only slightly adjust your probabilities based on that weak evidence. Your final answer should still have those high population fields, like humanities, ranked much, much higher than the small ones, like computer science.
And that leaves us with a final question to take with you. In a world that is just full of compelling stories and stereotypes, when you're hiring someone, maybe considering a diagnosis, or just making daily judgments about people, where might you be letting a vivid but weak story overpower the statistical reality? What weak evidence are you trusting a little too much?